The chapter 1 have some content is worth to introduce. So this is one, I think this is part of them. There is another description. That is, do you know what is a linear system? Okay, good. Have you studied nonlinear system? So I remember the Professor Fong mentioned that if you study the nonlinear system, you will find they will be very easy compared to the linear system. That's one master mentioned. Okay, I would say he is the master for dynamics. Okay, it means in our usual application, almost everything is nonlinear. But the kind of nonlinear can be ignored. As you may study later on for the nonlinear system, there are so many terms they called high order terms. They will be eliminated. But if you added on the high order term, the error become a little bit large, but it still can be ignored. So that's why I try to say over here is this is upside down. Yeah, if you discuss about the mathematics for we just mentioned, it's not quite complicated. It's mind complicated. It's not technical complicated. But for this case, it's quite complicated. What kind of case it is? This is a case the industry really wants. They want to do the grinding by robot. If we don't do the grinding, we just do the follow the trajectory. How can let the robot? How can you design the robot trajectory to follow the path? Okay, grinding 是研磨，他们都要做研磨。OK， 我们先不讲研磨，那是 mechanical 的部分哈，所以有很多的，所以现在的显学都不是 mechanical， 但是现在的 problem 的 issue 都是 mechanical 哦，所以非常有趣哦。好，trajectory 是路径。Say if I need to design a robot trajectory follow a curve path, I want to say the very special term they call freeform service. The freeform service is a curve. It's a face with a curve. How can you design it? In your minimal knowledge, how will you design it? How can you design a robot to follow a curve service? That's my question. Okay. I can name anyone. Anyone? Anyone want to volunteer to respond to this question? Yes. But is it possible? Yes, of course, this is one of the solutions. But is it possible? No, I'm not challenging you. I'm just saying in practical way, is it possible? Any other input? Yeah, 来。设 waypoint 应该要怎么 ？Waypoint 是什么？必经点啊。那要设几个？所谓的 freeform service, what is the freeform service? Let me write it down. Yeah, you are right. Yeah, we need waypoint. This is a special term called freeform service. I studied this long time ago, but it's called, depends on what is the purpose. The main purpose is for good looking, but the second purpose is for the streamline for some vehicle. The vehicle, not necessarily the car. The airplane is one of the vehicle. So the freeform service sometimes is a function, but sometimes it's just a random shape, I would say. Random shape. Because you can manufacture the freeform service easily by mold. Because you can use the molding. Yeah, to press, to ejection, to forge the freeform service. Okay, any idea? There's a hint over there. Yes? Vision for what? How can it manipulate? Okay. So the students mentioned about we use the vision to see the service. Okay, see the service. Can you imagine the calculation? How can you do the calculation for? We need to come back to one thing because you are engineer, I hope, and if you use the vision system to see one service, how can you detect the coordinates? Can you? I think you will immediately come out, oh, I have a 3D vision, right? Could be. Okay. This may be one of the possible solutions. However, grinding, mechanical. Let's go back to the mechanical part. What is the working condition for grinding? Can you imagine it? You guys are almost a mechanical guy or electrical guy. It doesn't matter to me. You need to know the engineer, right? When you do the grinding, what happened? 研磨的时候会出现什么 ？OK， 那火花里面是什么 ？Dust. There are so many dust, so the vision system basically fail. So this is a true condition. I will tell you, it's a true condition. Right now, no, I don't want to announce the answer. Any others? There's no answer actually. There's no best solution. There's no best solution for any engineering application. The best solution is you don't need to spend any money. So there's no best solution, okay? But there's a good solution. Okay, but vision has this kind of challenge. Yes? 再讲一次 Yeah, force detection maybe is a good way. Okay, so so far they use the force detection, yes, but still not so success. I would say most of the reason will be the price and noise. The noise is not the noise you hear, it's the signal noise. Okay, so it's quite difficult. Okay, thank you for your feedback. And I would say, yes, you are on the right track. You know, when you enter the working environment, the first skill you need to have. Do anyone have idea? What is the skill you need to have? Write down on your white paper. Maybe later on we will share with that. We continue our class. Okay. What is the most important skill you need to have when you enter the working environment? Okay. So for this case, yes, they use the vision as the your classmate mentioned. And can you imagine that how complicated it is? Because you see is not your coordinate. What you see is vision's coordinate. It's not robot's coordinate. So that's why we need to correlate. We say correlate. Build up the relationship between the vision and the robot. So we need a transform matrix. And still, okay, the classmate mentioned we use the force sensor. That would be good one. But still come out the issue is how large is the force we should set up, and how far should we adjust the grinding wheel to the material, something like that. And they still have an issue for position. You may need to adjust the position all the time. How can you do the repeated calculation? Okay, so it all come out with the issue, say you need to define the position simultaneously. This is a hard word. 要同时，你就必须要去计算下一步要走的这个位置，位置。So although right now, as I mentioned, maybe if you go to the seminar for your graduate school seminar last week, they mentioned a little bit about the robot. The robot is so fancy; they can do whatever you want them to do. But it's not so, I would say, easy to the engineer, I would say, to come out a kind of robot. Because we are still need this kind of very fundamental thing and very difficult to do the mathematical calculation. Of course, for the computation, right now there are so many tools can help us to do that. So you can purchase like they call motion control car, and the motion control car can perform the kind of stuff, yes. And you can also replace the motion control car by your own algorithm to design the trajectory. Yeah, depends on what is the compact size of the robot controller. Okay, so go back to this topic is how can you define the trajectory? In this case, they grinding tool, home position. They actually they want to follow the contour. Contour is the shape from the surface, from position A to position B, something like that. And we need to no, they did not mention too much. Okay, maybe next one. Okay, but they just put a CCD over there. Okay, that's all. Okay, so they did not mention too much. I think they just give you an example and how complicated it is. And also, there's another field I want to mention that it can also be category into robotics also. It's our, we call last week called end-effector design. The end-effector is not as easy as we see before. End-effector is 夹爪. So far, the very common one is we use the clipper. They call clipper to do the pick and place motion. But in the future, we need at least 3 to 5 fingers to perform more like human motion. So in this case, how can we already have a trouble to control the arm, because the inverse kinematics is a little bit difficult. How about the hands? So how can you control the position of the hand fingers? I think you need another chips over there. So hopefully right now the chip is cheaper. Okay, so you need a chip for your hand, you need a chip for your arm, and you need a chip from the walking, or you need a lot of chips. So invest in a chip, it seems a good way to do that. Okay, but for the machine itself, yes, it's so complicated. So when you want to grab something, you need a very fancy mechanical design and also very compact actuator. So I would say this is another field is worth to watch. I would say watch because we are already done something for that, but it's good for watch. Maybe in the future it's good for the business. Okay, so this one just mentioned about the normal robot go with the very unique trajectory. Okay, there will be actually you will have a practical activity. You design the trajectory, yeah, because you need to write your name, yeah, you write your name, and this is part of open, I would say open question without a correct or incorrect answer, because this one have a correct answer. If your grinding is fail, then there's incorrect answer, right? Oh, the one experience I can share with you is for the grinding. There's another issue is what kind of product need to grind? What kind of product? Is it something from the casting? What is casting? Oh, 铸造. Okay, when you cast out the component, sometimes it has some we call burr. They call burr, B-U-R-R, burr, 毛边. So when you do the grinding, you will unexpect to grind the burr. So it will affect a lot of stuff, yeah, for the situation. So there's another, there's an experience sharing. So that's why they are not so successful for this reason. Okay. Ridge motion, we are going to. Okay. So we need a forward kinematics to design our robot. When I say design our robot, I think I mentioned last time is we need to define our working space, or like one robot, how high should it be? Should a robot higher than us, stronger than us, or they should smaller like a kid? It all depends on what do you expect it to do. Or it, I would say it. Yeah, it's it. Okay. Same. If you want to work in spatial environment, how long should we reach? How heavy should we carry it? They will all depends on your design. So sometimes if you need to design this in the preliminary time, you need a forward kinematics. So it define the type of robot you want to design. Then you use the forward kinematics to define the working space. They will become easier because it is non-linear. It's a non-linear motion. Yeah, it's not I rotate 1 degree, then you can move 1 centimeter. No, that's not it. Okay, this is one of the application for forward kinematics. Okay, and over here there are some example we will introduce later on. Previously, I did not mention this part, but it become more and more important. So this semester, I will mention the velocity kinematics. When I say Jacobian matrix, everyone mentioned, oh, it's a velocity matrix. So when I go further detail, what is the velocity matrix used for? Okay. In my word, yeah, because that's what we do, and we try to explain the very hard word to you guys. Or do anyone want to try? Have you everyone heard the Jacobian matrix before? 是有吧? What is that used for? Can you explain a little bit to us? 忘光了. Anyone? Okay. 你看过吗? Okay. I like a theory, use one sentence to describe it. Okay. but this one maybe cannot. And then let me tell the whole picture. Okay. Yes, it discusses about because we have a position, right? Position. What the velocity used for? No idea so far. But when you want to move, because when we, as we understand, the robot use the motor. Motor belong to what kind of actuator? Is rotational or prismatic? Or is periodical? What kind of actuator? What? Rotation. It's a rotation. So when you do the rotation, that's a little bit difficult to figure out how fast is the arm, right? So the Jacobian matrix, in briefly speaking, is how can we connect with the actuator velocity to the final velocity? Done. Say it again, okay? So the Jacobian matrix builds up the relationship between the actuator, no matter what types, to the final trajectory, to the end effector velocity. Okay, so if you were prismatic actuator, 直线型的滚珠, but the prismatic is still driven by motor, right? Okay, should be the same. Okay, so it's not different. Okay, so eventually they build up the relationship. There's a Jacobian matrix in between, and here is a outcome, the end effector velocity, and they will related to the actuator. So in this kind of concept, you will see, okay, yeah, I know what's going on, and then we'll be okay so far. Okay. So this Jacobian matrix used for. So as I mentioned, as it mentioned over here is if you want to follow a contour with a constant speed, before we afraid the arm robot to do two things. One is constant speed because it's difficult. The speed always vary. If you want to very precise constant speed, that's very difficult. The other thing is a straight line. The robot almost cannot go straight line. So it's a little bit to adapt into the surgery. So the surgery, only one type of the robot succeeds, and the others seems a little bit difficult. I remember there's an example for high wind. High wind want to explore their business into the medical business. They want to do the surgery by the robot. The request to each then if there is an emergency, I need one button. When the machine in the field, the one button is stand for what? Stop. But the robot, they say, they want to retrieve the tool with the original path and come back. We cannot do that. Yeah, it's very difficult to do that. Because when you do the surgery in your head, then they need to come back with the original path and come out. So that's the requirement we cannot fulfill. So yeah, but maybe right now they can do that. I'm not sure. I never saw that before. Okay, so there's only one robot, surgery robot. Do you know what's the name? You should know that because you are engineer. Why is a very popular? No, not this one. It's popular. Surgical robot is Da Vinci. Da Vinci is the most popular robot in the world. Yeah, so yeah, it's a quite a good knowledge you should know. Okay. When we want to design a robot, we use forward kinematics. But what is the inverse kinematics we use for? We did not mention that. But the inverse kinematics is essential. because you already know the end point. What is the angle between the arm? We should calculate. Okay, or we cannot go there somewhere. So there's a human brain is so superior than other computing, than other computers also, because we don't need to do any computation. We can reach whatever we want, especially for athletics. They play the ball with the game, and they can pitch so precisely. That's quite amazing. Okay, so for the inverse kinematics, we are dealing with, we need to design an end-effector position, right? But for each end-effector position, what degree of the actuator I should turn, I should rotate, they will be the critical input for them. Okay, so inverse kinematics. There are some examples, so we will go through this part. I believe when we touch this part, then the class will be close to the end, and you should have some idea then. Okay. Path planning and trajectory generation is normally I did not touch the part, but it seems necessary if you really want to operate the robot. There are some there are some difference between, there are a lot of differences actually between the path planning and the trajectory generation. Okay, so when you design the path, as your classmate just mentioned, a waypoint. What is a waypoint? Waypoint is a very specific term. It's called master path point, waypoint. So when you say waypoint, is I need to go here precisely, and I need to go there precisely, and that's done. So in our human being mind, we only define 2 points. But when you define 2 points, the robot will generate its path, its trajectory for so many reasons. For example, smooth moving, fast moving. If it is logical, it's very fast moving. So I would say for the path planning is okay, but why should we need a motion control car? Is we need a motion control car to generate the whole trajectory for the robot to do the computation. No, inverse. We input the waypoint, then the motion car can compute all the trajectory. Then the robot can move maybe as smooth as you want or as quick as you want. Okay, so the trajectory is one of the maybe vanished technique we need to know right now, but I think we still need to introduce a little bit. Okay, and of course the control is quite crucial because you will have some sensor, but over here it just mentioned about itself, or you have some sensor input. For example, we don't touch too much this part, but at this age, in this year, this time, you guys already can operate the robot according to the vision coordinates. Because my students already, they don't have too much background. They just read through the whole material from internet, material from textbook, then they can perform this kind of project. So right now, in your age right now, there are so many resources. There are so many resources you can retrieve or from internet, from somewhere. But as long as you can read through the whole technical part, then we'll be fine. 所以现在在针对这个整合 vision 跟 robot 这一块是完全没有障碍，对你们来讲，如果对你们大学要毕业的没办法做到这一点，基本上你可能要稍微检讨一下。当然，前提是你有兴趣，也许你有兴趣的不在这里。但是我现在讲的是说，如果你想要做，我们已经有好几组专题生，谁学过这种东西？就上完 robotics 而已，怎么知道怎么视觉整合？怎么知道怎么坐标整合？但是网络上有太多的资源，这个资源啊，是怕你不看而已啦。基本上都是可以帮助你整个系统把它完整的建构出来的。我们已经有好几组，不是专题生，还有研究生，基本上就是没有都不需要说，我们一定要有正规的课程，然后才可以做这件事，就把它制造，把它设计出来，包括视觉的，包括检测的、校正的，然后还可以在空间中去调整它的这个所谓的轨迹路径的。这个东西其实都是你们可以 reach 到的不难的题目，不难的题目，所以给各位一个概念，给各位一个概念。Okay, so there are other interesting chapters. Then maybe we don't have time, especially for the last one, the vision-based control. Yeah, if you don't have any platform, you just listen what I'm mentioned here. You'll get boring. So the best way is you integrate by yourself. As I mentioned. As I discussed with our classmate, later on, let me see if we have a model. Okay, I think that will be the O.